The lens materials from the past are not the same as the lens materials of today, with thinner center thickness, flat designs, and higher index materials. Patients today demand the best technology, and that is a thin lens with no glare. As the no-glare lens category grows and our use of higher index materials increases, it's important to master best practices of handling these types of lenses. With the sophisticated lenses of today, we'll demonstrate that edging thin lenses with no glare isn't difficult, it just requires best practices. With proper care and handling, along with proper tools, equipment settings, and procedures, edging thin-centered lenses can be as easy as working with standard plastic. You may be asking, why should I take extra care when handling thin-centered lenses? Quite simply, polycarbonate and high-index thin-centered lenses are flexible. Compared with standard plastic, poly or high-index material is thinner throughout the lens, so there's less material to stabilize the lens during blocking, edging, drilling, grooving, or mounting. The stress potential is even greater with today's wide A, short B frame styles. This creates a low-minus lens that's narrow and thin at one point, yet long and thicker at another. And avoiding flexing becomes all important when you add no glare. Today's best scratch-resistant no-glare technologies have a crystalline structure. If the lens flexes too much, the no-glare coating could craze. This is the cracking on the no-glare coating that can be any pattern based on the type of stress on the lens. Another threat to thin no-glare lenses is excessive compression. The problem is illustrated in this simulation. A hollow block is used during edging, which does not allow for pressure to be evenly distributed across the lens. Stress points result, represented by the color change in the lens, which can also lead to crazing. Finally, as lenses have changed, edging machines are changing to handle the demand for these thinner lenses. You can successfully edge any lens on any machine if you follow a few best practice procedures. Let's look at a series of steps designed to make you more successful when edging thin lenses, whether you have the latest automated equipment or an older edging machine. It's essential to start with a well-maintained and properly calibrated tracer. Calibration should be conducted at least once a day. This will enable you to keep the correct size and shape. For example, incorrect sizing will increase pressure on the lens when mounting by flexing the lens as demonstrated. There are several types of blockers, but the important part of this process is choosing the correct blocks for blocking and edging thin no-glare lenses. For proper blocking of a thin no-glare lens, we recommend using solid, hard plastic blocks as pictured if possible versus using a standard block with a cutout center. These blocks come with different front curvatures that are designed to match the front base curve of the lens. Find the block that comes the closest to matching the front curve of the lens. This recommendation reduces slippage and chuck marks due to flexing of the lens. Once you have the right block, choose the matching leap pad. Apply the leap pad and place the block into your machine. Next, align the lens in the blocker. Finally, apply the block gently, avoiding excess pressure on the lens. As with blocking, edging requires a well-maintained and properly calibrated machine. With the variety of edgers in the market, please refer to the manufacturer's guidelines for proper settings and calibration. Most edgers today provide special software which enables you to modify feed rate and chuck pressure for handling thinner, no-glare lenses. Some newer edgers have fragile mode settings designed specifically for thin lenses. As a general rule, manufacturers advise against high clamp pressures and excessive running speeds. Also, refer to the owner's manual for recommended pressure or force settings. It's important to check the condition of your cutting blades on a dry cut edger or your diamond wheels on a wet cut edger several times a day. Recommendations vary on how often the cutter blades or diamond wheels should be replaced. Once more, it's important to refer to your machine's technical guide for this information. Some edgers have a count that actually tells you when to change the blade or wheel. Routine wheel dressing or blade replacement should be part of your overall maintenance schedule to avoid any problems, like changing the oil in your car at recommended intervals. Dull cutters generate heat, twisting, and flexing against the chuck, which can damage the lens surface. Most problems with edging thin lenses can be traced to improperly maintained equipment. Also, poor condition of cutter blades or diamond wheels will reduce the life of the motor. If your equipment's up to par, the rest of the task is fairly simple. Let's demonstrate how to edge a no-glare minus power lens. This will be for a short B measurement frame, one of the most challenging combinations with thin center lenses. Why is it challenging? Recall that unlike thicker plastic lenses, most high-index lenses are relatively flexible. Unlike a normal-shaped lens with even support from the center to the cutting edge, the lenses we're about to edge have a long A measurement and a very short B measurement. So the nearly rectangular shape creates the potential for uneven stress on the lens. You can see from this setup, the block and chuck are close to the edge along the B measurement and therefore provide considerable support. On the other hand, the A measurement extends far beyond the edge of the block and chuck, where the lens receives less support. If cutting tools aren't sharp or the chuck pressure is set too high, flexing and stress along the A measurement may cause the lens to break or the coating to craze. The next step is preparing your lenses for edging. This is fairly simple, using steps common to all lens materials, even if you're faced with a difficult job. One of the secrets to edging thin lenses is to always use the matching size clamp and block assemblies. Mismatched sizes, for example using a small clamp with a large block or a small block with a large clamp, will generate additional stresses that may cause the lens to flex excessively. While you should use the largest block and clamp assembly possible, for short B measurement lenses, you'll use a standard half-eye clamp and block. For larger diameter lenses, use a standard full-size clamp and block with a full-size chuck body. Next, make sure you're running the job on the correct setting. For example, material, polish, fragile mode, and bevel. Please refer to your manufacturer's recommendations. During the whole process, sizing is one of the most important issues. That's why it's necessary to have daily calibration of the tracer and edger. With today's edgers and technologies, the goal is to cut the lens in one cut. If possible, stagger jobs by alternating different lens materials or allow the cutting blades to cool before edging the next thin center lens. Finally, let's re-emphasize that replacing cutter blades and truing the edger wheel is critical to turning out a great final product. Before deblocking, remove the lens from the edger and immediately wash it in clean water. Deblocking may be one of the last steps, but it's also one of the most critical. The proper technique for deblocking is to use deblocking pliers. Twist the lens off the block, using either a clockwise or counterclockwise motion. If you attempt to pry off the block, knock it off by force, or use improper tools, you'll flex the lens, which will most likely cause it to craze. There's an art to beveling, polishing, grooving, and inserting lenses into a frame. It's like working with fine jewelry. The key principle, as with all steps in our process, is to avoid stressing or flexing the lens. Don't force the lens into a metal frame by tightening down the screws. With any frame, especially plastic frames, you always need to cut the lens to the correct size. It's easy to insert oversized lenses by heating the frame. However, it's not recommended, as it's proven that plastic frame material has memory. Therefore, the frame will always go back to its original shape and size. The result is stress on thin, no-glare lenses, which can cause crazing. This memory effect can take time, so the crazing can occur after lenses have been dispensed to the patient. While wire and plastic frames are more likely to cause crazing, care also needs to be taken with string mounts to ensure that the string is not too tight. With drill mounts, the screws must not be overly tightened. Another key is to avoid using alignment tools, which were originally developed before the introduction of today's thinner materials and no-glare coatings. If used, these tools may flex the lens. Try to get it right the first time by handling thin lenses carefully when finishing for frame insertion. As with every step in the process, it comes down to performing common procedures with an uncommon eye for consistency and accuracy. As we said in the beginning, etching a no-glare thin-centered lens isn't overly difficult. The practices are just a little different from standard plastic lenses. To summarize, it's important to remember 3 key points when handling today's more sophisticated lenses. Let's call them the 3 T's: tools, technique, and touch. Successfully completing any job at the edging bench comes down to using the proper tools, from sharp cutter blades and wheels to clamp and block assemblies. Using the proper techniques, from recommended machine calibration and setup to proper deblocking methods. And finally, having the right touch. A gentle touch when handling these lenses from start to final frame assembly. Remember these best practices and you'll be ready to handle the future of thin, no-glare lenses. Thank you for watching and good luck with your thin center lens edging program.